I sold my table saw, which is a bit sad. I've had it for every episode of The Wood Night. In its place, I've bought this new Sawstop PCS, and thanks to Carbatec, I have a nice industrial base to put it all on. In this video, I'm going to go through the process of setting up a cabinet saw, specifically all the calibration, and just a little bit of the assembly. How do I get down from here? The mobile base arrived a few days before the saw, so I had a fun time unpacking it to find that it was mostly air. Carbatec were kind enough to provide this base. It makes moving a 200 kilo plus machine an absolute breeze, and having 4 swivel wheels means that it can turn on a dime. It's nice that the industrial mobile base doesn't need any assembly, but it may require just a little bit of adjustment, which is these 3 screws here. If you don't know how this base works, there's a bottle jack under here, more or less, hydraulic jack. And as you press up here, press down here, sorry, with your foot, these 2 sections here, which are linked together, will raise up and raise the entire saw. The adjustments to the lowering lever, which is here, is to make it go down slower or faster, depending on what needs adjusting. So at the moment it's quite slow. That's because there's not a lot of weight on it. It should have about 200 kilos when the saw is all assembled. So we can adjust these fairly easily with a 3mm Allen key. These get backed off. And then this is free to slide around, so you turn it one way to make it faster, the other way to make it slower. So if we go to one extreme, that should demonstrate it. Without adjustment, that goes down much faster, which is too fast for when there's an actual saw on it, but it's a lot easier to demonstrate when there's not a saw on it. I skipped a few steps with unboxing and flipping the saw upright because this required 3 other people to help. Cabinet saws are no joke when it comes to the weight. You do really need people to help you out, or an engine hoist or something like that. Absolutely all of the cast iron surfaces, and even most of the other surfaces, were drenched in an oil substance. Now, it's not like the old Cosmoline type product that's very thick and waxy, so no special solvents are needed to clean it up. It was really just the sheer amount of oil that took me by surprise. Clearly, in the past, Sawstop have had issues with cast iron surfaces being rusty on delivery, so they've gone for the no risk approach, and afterwards I felt like I was ready for the deep fryer. I was just coated in oil, but at least it cleaned up easy. The base secured to the saw with 2 self-tapping screws. The saw arrived in several different deliveries, partially because of where Carbatec had stock and partially because of the courier company splitting it up. So for a while all I had was the mobile base and the saw, no fence rails. That didn't stop me from having fun twirling it around. I'm going to skip over a fair bit of the assembly and focus more on the calibration side, but it's worth noting just how freaking good the assembly process is with Sawstop saws. All the hardware comes in colour-coded blister packs, which is then referenced in each step of the colour-coded manual. Setting aside the huge amounts of oil and heavy weights, this level of instruction is something IKEA and Lego can only dream of. So there's sort of a hierarchy of saws. At the lower end, you've got your job site saws, which are super portable, more used for construction grade stuff. You can throw them in the back of a truck, take them to job sites, no problem. Step up from that is what I had previously, which is a contractor saw. Contractor saws are usually cast iron, they've got a fair bit of power, they have induction motors, that sort of thing. And this is a cabinet saw. There's probably 2 main differences between a cabinet saw and a contractor saw. Contractor has the outboard motor, which, obviously this doesn't, so that was hanging off the back, and the trunnions were mounted to the table. In a cabinet saw, the trunnions are mounted to the cabinet, and the top is mounted to the cabinet. By decoupling those 2 things, that means that you can adjust the table, pivot it back and forth, to get it in line with the blade. So I want to have these Mitre slots parallel to the blade. Why do you want that? Well, that means that your Mitre gauge is going to run more true when you are doing crosscuts, so it's going to be 90 degrees all the way. Also means when you set your rip fence to be parallel to the Mitre slots, it's then also parallel to the blade because you've made the Mitre slots parallel to the blade. You can do that on contractor saws, but it is a lot more work because everything's coupled together. So the first thing we need to do is measure whether the blade is parallel to the Mitre slots or not, and if it's not, record how much it is so that we can then make adjustments to it. So this jig here runs in the Mitre slot. It has 2 ball bearings here and some magnets on the other side so that it's always hugging the slot as tight as possible. And there is a dial indicator at one end. I've gone for an analog dial indicator rather than a digital one, because if I use a digital one, someone's going to say it's not accurate enough, but either will work just fine. This will tell us hundredths of a millimeter. So the way that we do this, we install a blade, we follow one particular tooth, doesn't matter which tooth, but you just want it to be the same, around to the front and back of the blade to measure how far it's out. We're aiming for, I think it's about 0.05 of a millimeter difference, and that's sort of within spec then. Otherwise we'll need to make some adjustments. So step one is to mark a tooth. It doesn't really matter which tooth, but we just want to make sure it's consistent. Next we need to zero our dial indicator. So that is reading 9, so we want to adjust that to 0. And now I can rotate the blade around, line the dial indicator up with it. So I can see that we're 0.11 millimeters out of parallel, so we do need to make a few adjustments. We start by loosening the bolts that attach the table to the cabinet. These two outside bolts, they're a little hard to see. The two inside bolts attach the trunnions to the cabinet, so these are the table ones that we need to loosen, not take off, just loosen. There are two matching ones inside the cabinet which are a little bit harder to access, and this is going to vary from saw to saw. You may need to go in through the cabinet, which is what I had to do here. With the table loosened, there's a pivot pin on the front, and then there are two set screws on the back that actually pivot it. So that's accessed through this hole here, and there's a matching one on the other side. So we need to loosen one and tighten the other. Because on this side of the blade, it was a positive number, so it went from 0 to 10 rather than 0 to -10. We need to loosen the right side and tighten the left side. This should reflect a change in the dial indicator, but this is going to be hard to see because it is, well, 1/10 of a millimeter that we're adjusting. So I've loosened one side, now I need to tighten it. Hopefully we'll see that move as well. Oops, that's the wrong way. Maybe I've got that back to front. I did have that back to front, but the process is the same. You're just adjusting one side or the other. So then I just needed to re-zero a couple of times and re-measure, doing very small adjustments at a time. So we check here, it's on 0. Follow that tooth around, and we're on 0.06 mil, which is pretty good. That's within tolerance. This 5mm ball head hex screwdriver comes with the T-glide fence, and this is actually perfect for the task because you can get in there easily, and it has a nice handle on it, so you've got a little bit more torque than this tiny little thing, which is just hard to grip once it's in the hole. It just doesn't work quite as well, I find. So this is really good for making those adjustments. When you go to tighten everything up after you've made your adjustments, make sure you go corner to corner and do it in small increments so that it doesn't move on you, because I didn't. And then it threw my settings back out to 0.09, so I made a marginal increase. I had to undo them slightly, and that's what I got wrong the first time, is I undid those bolts a little bit too much. Small adjustments are what you really want to make, and I've got this down to 0.03 millimeters difference, so that's well within spec. You're aiming for 0.05, or I think that's 2 thou, something like that. So it's better than what it needs to be. It's something that's good to check every now and again, but shouldn't be something that needs constant adjustment. But again, just go very slow, make small adjustments. It's still only going to take you 5-10 minutes. It's not a big deal to do on a cabinet saw. Touching these tables is a pain in the backside. If you've got a helper, that makes it a lot easier. You have one person hold the table, the other person can bolt it in. You only need them in finger tight. Then you can let go of the wing, and then it's time to align them. Start in the middle, make sure the seam is as close to flush as possible, then work your way out. If the wing is not perfectly level, it is okay. You just want these lower rather than higher than the table. Now again, you want it as perfect as possible, but that's not always possible, and it's not always worth spending a long time dialing in everything to the millionth of a millimetre to get everything perfect when thermal expansion and wood movement is going to take everything out. The thing you need to realise is the main table is your reference surface. These are support tables. If they are off by a tiny amount and they're lower, perfectly fine, won't cause any issues because you're always applying pressure to the middle of the panel anyway, near the blade. If they're higher, that can cause an issue because then things are going to be tilting up. Best friend here is a 13mm socket and probably soft-faced or nylon-faced mallet to just coax things into place. This is just a lot of back and forth, getting it as flush as possible and tightening from the middle outwards. Go too high, use a tippy tap with a mallet. Go too low, lift from below. It's a slow process, but it's not a difficult one. The rails, the back rail in particular, doesn't need any real calibration. Get the wings in one plane, then lock it in place with the rail bolts. It's really mostly just for support. The front rail is attached in the same way. I entirely skipped recording the extension table because it's just bolts. Once the table's all attached, the rail are all attached, is this front tube that the fence rides on. And from past experience, this is heavier than it looks and also a lot slipperier than it looks. So you have to be very careful that you don't knock it off because every time I've done that, it's been a shin-seeking missile. Once you've got one finger tightened, it's a lot easier. I'm going to hop down the other end and do one down here. That way it cannot slide off and get me in the shins. The tube that holds fence is loose and we need to set that correctly. You don't want too much of a gap, otherwise it just won't glide smoothly. The way they recommend you do it is you get the fence, you clamp it down, then you want a gap of 1/32 of an inch, and if you're like me, that means absolutely nothing. Turns out that's about 0.79mm. So if you've got a feeler gauge, 0.8mm will do. So we push it up like that, and then we can tighten the bolt underneath. And with that tightened at one end, we can undo it, slide it down to the other end, and repeat that process. So this will now glide smoothly from end to end, and when we lock down the fence, it doesn't shift around too much because it's been kept relatively parallel. So now I can go ahead and bolt in or tighten all the bolts underneath so that this rail never moves. If you've come from job site saws, you might be quite confused that this only seems to lock from the front. That's because it only locks from the front. Doing it this way with quite a wide surface means that it's very stable, and if you have it locking on the back, it can end up catching on the back, so it ends up tightening one way or the other rather than straight and where you actually meant it. The fence needs to be square in two directions. First, it needs to be square vertically and square to the mitre gauge slot. Checking for square vertically is super easy. You get a square and you go, oh, I can't see any light, and you're done. In this case it's bang on, but if it wasn't, there are two screws on the T-piece of the fence that you either drive one in or loosen one out, and that just rotates the base of the fence, so when it clamps down crooked or straighter. But in this case, we don't need to do it. The other one is a bit more involved, but it is more important, and that's making sure that the fence is parallel to the mitre slots that we made sure that the blade was parallel to. We either want it parallel or towing out slightly away from the blade. If it toes in, that can cause some dangerous situations when you're ripping wood. There's two ways we can go about getting this into alignment. The first is take the fence to the mitre slot, doesn't matter which one, lock it down and see whether it's parallel with both edges, just using your finger. Take a little bit of back and forth to make sure it's flush with one end, and I can tell that this end is a little bit out compared to this end. The other way is using the same jig we used to align the blade in the first place. This is a little bit more accurate because you've actually got a number to work with, but just using your fingers is a pretty good way, and it usually will get it close enough. I'm just going to zero it out on the front of the fence here and then check the back. And we can see that we are about 0.25 of a millimetre in. If it was 0.25mm out, that would be okay, but at 0.25mm in, that's a little bit dangerous. So we need to make some adjustments. On the bracket for the fence, there are these set screws here, one on either side. We need to adjust them in or out to move the fence. In this case, we want this one to come out a little bit more, which should shift the whole fence away from the blade. Add that back to front, but that was easy enough to go back and forth on. You can see it was 0 here at the front of the fence. And at the back here, we've gone to minus 92, minus 8, I guess. If the fence was towed in, we'd see this increase, so we're definitely going in the correct direction. So that's a pretty good result. There are just a couple of things left, finally, before I can plug this in and turn it on. First is the blade brake positioning. Now obviously this is a Sawstop exclusive thing to set up, but every time you change the blade on one of these saws, you need to adjust the brake positioning. They include this little gauge here. The end piece is what you need to put between the blade and the brake, and then included Allen key adjusts the lever that moves the brake back and forth. It's very difficult to shoot because it's in the dark in a small cavity where my hands have to go into. Yes, this has to be done every blade, every time. It really doesn't take that long from experience. Last thing we need to adjust before we can turn the saw on is the throat plate. So with the throat plate installed and the blade lowered, we can try and get this as flush as possible by just using a combo square and the adjustment screws. So the idea is we don't want to be pushing our workpiece across and then it gets caught on this lip here. Likewise, we don't want it to suddenly come up when we're trying to cut, then drop back down. So this needs to be as flush as possible, but particularly the back edge here. And there is just there's 4 grub screws that can be adjusted. Shouldn't take too long. The fence scale still needs adjusting, but to do that I need to turn on the saw and make a cut, then measure that. Before I do that, I'm just going to put some paste wax on the cast iron. A lot of people are fans of carbon method, I think it is, or bow shield, or all these silver glide. I've been happy enough with paste wax on my cast iron tools. It doesn't keep it necessarily as stain free as the carbon coating stuff does, but I've had no issues with rust or needing further lubricants. So small amounts of paste wax, let it haze up and then buff it off. Pretty much any paste wax is going to do the job. Obviously if it's a harder wax it's going to work a bit better. So car wax will work just fine. I know people use turtle wax. I use what I've got on hand, and when that tin runs out, I'll look for whatever else is on the market. The fence set to 50mm to do a test cut to calibrate the fence scale. Without moving the fence, I can measure the cutoff. We've got 51mm and I set that to 50, so we just need to make a small adjustment. So I just need to loosen these 2 screws and adjust the indicator to go to 51 to match our cut. Now I can do another cut, make sure it actually reads 51. I think within 0.01 of my target is good enough for the fence scale calibration. The saw's up and running. I've been using it for about the last week, but I do have 2 very small minor modifications to make the user experience slightly better. At the end of the fence rail there is this plastic cap that just covers it up, so we can pop that out with a screwdriver. It's just held in with little barbs. And I've got a 3D printed drawer which I can put the Allen keys that came with the Sawstop. So this will do things like opening up this cabinet door for the large one. The small one will do the throat plate adjustment. Good to have them on hand at all times. Fence has this metal tube and then the 2 faces on it. So it creates a nice little platform here. I like to keep my remote for my camera as well as for my dust collection. And I love to put a tiny little calculator here. This is a great one to just use some double-sided tape to adhere down. This way I've always got a calculator on hand. It doesn't go walkabout around the workshop. It won't interfere with anything. It's below the table saw, so I can still attach some jigs to it if I want. And if I need to know some archaic measurement system like imperial, I will now know that 1/32 of an inch is 0.79 millimeters for cases like, say, when I'm setting up a table saw. I mentioned that Carbatec were kind enough to supply me with the industrial mobile base, and with this fully loaded up, so the saw is fully assembled. It's super easy to raise the whole thing up, and then with one hand I can move it in any direction thanks to the 4 swiveling wheels, even though I've got the legs on and the cast iron wings and all of that. So this is great for those few times when I need to move it around the workshop. And that's it, that's setting up a cabinet saw. Between the different brands there's not going to be a whole lot of differences. Some of them, like Sawstops, will be a little bit easier. Calibrating the Mitre rails, for example. Not all cabinet saws have that pivot pin, so they require loosening 4 bolts and tippy tapping all 4 corners. But overall the process is going to be pretty similar between them. It is something that I will check periodically to make sure that everything stays in alignment, but that might be once a year that I check type thing, if even that often. Once again, thank you to Carbatec for supplying the industrial mobile base. It is a really nice piece of kit, and it's quite annoying that my other big machines don't have quite as nice a mobile base on it. But that's Future Paul's problem, and thank you for watching.